Hello, Python Padawans. Let's talk about the third element in Unit 1-2. And this lecture, we're going to talk about computing with numbers. It's the different type of numeric data types. You kind of starting to get familiar with them as you work through some of the first few exercises and homeworks. But what we want to do today is we want to talk about some more specifics about them. So let's go ahead and get started. In numeric data types and computing with numbers in Python, it's important to keep track of what data type you're working with, whether it's an integer, a number with no fractional parts, whether it's a float, or some other type of numeric data type. Those are the two primary ones, though, that we'll talk about this semester. We're also going to talk about the math library. The thing about the math library is that it allows you to have some extended functionality. So we need to know how to import a math library. Later on, we'll work with a number of libraries, but the math library specifically. We also want to talk about accumulators. So we talked about for loops. If you do something repeatedly, what about in that for loop sort of accumulating or collecting a value that builds as the loop repeats? That's an accumulator. We're going to talk about that as well. So what are some of the data types we've talked about so far this semester? Well, the first two data types we've just briefly talked about are integers and float values. So integers are numeric data types where it's a whole number. Float are data types where you have decimal places, something with a fractional part. And then we've talked about strings, which is anything inside of quotes. And next week's material, we're going to talk a lot about strings, and strings become a very large part of what we do as we work through in Python. Python is a string and data manipulating monster. It can really do a lot. So we'll talk about that as well. But for now, let's just talk about the limitations and controls that are on us when working with things like integers and floats. So what if I have two integer values and I say, starting with two integers, total equals 60 and quantity equals 23. If my average would be total divided by quantity, right? I say average equals total divided by quantity, and then I ask Python to tell me what's in the average variable, right? So I've assigned 60 to the variable called total, 23 to the variable called quantity, and dividing total by quantity, I take that result and assign it to a variable called average. So then what is in average? Average is going to be 2.6, this big long number. And if I ask Python to tell us what data type this number is, you can already tell it's float because it has decimal places, right? This is an integer, 60. This is an integer, 23. But this is a float, 2.60869, whatever. It is a float value. And in fact, we talked about the operators like the divided by sign here, that if you use divided by, you always get a float as a result. And that's true. So the operation you perform can determine the resulting numeric data type. In one of the homework assignments you did for last week, you use the input function to get a value from the user. And by default, the input function returns a string. So if you need it in a different data type, and you were prompting the user for a name and an age, if you needed that age to be a numeric data type, you had to convert it to one. And we use the eval function for that, but you could also use the int function for that. We'll talk about those functions here a little bit later today. So even a lot of other values do this. So if I say 60 divided by 20, I'm going to get 3.0, in other words, a float value. If I do 100 divided by 2, 50.0, 50 divided by 25, 2.0. If I say x equals 50, y equals 10, x divided by y, I'm going to get 5.0, and I'm going to even be able to check if I divide x by y, what data type that is, and it's going to tell me that it's float. Now the string data type can store text, but can also be used sort of mathematically. For example, if I say a variable called first equals, in quotes, Joe, and last equals, in quote, Hernandez, so let's say first and last name, and I want to print first comma last, we've done something like this in homework, we would get Joe and a space, that's from the comma, Hernandez. If I say name equals first plus last, That's odd. How do I add two strings together? What it does is it concatenates or compresses them into a new single string. And when I print it, it says Joe Hernandez. If I say first equals first times 2, again, first was Joe. How am I multiplying it times 2? In fact, I'm replacing what's in the first variable. I'm assigning it what was in it doubled. So not Joe, but Jojo. And when I print it here at the end, it says Jojo Hernandez. So I can do these things sort of mathematically with strings to manipulate them, adding two strings together, multiplying a string by an integer. I can't multiply it by a float, but I can multiply it by an integer and that sort of thing. So in a way, we can work mathematically with strings as well. So what are the data types for these values? Try it and then play with it. But if I just look at a couple of these, how about 5 plus 6.2? Well, it's 11.2, so that's a data type float, right? How about 10 divided by 3? 10/3. That's going to be, well, it's divided by, so that's just going to be a float value, right? I'm going to get 3.333 repeating. And if I look at the next one, it says 10 double/3. So let's take a look at that. 10 divided by 3, that gives me a float. 10 double divided by. This is actually called integer division. I get an integer as a result. That's helpful. If what I wanted was an integer, I now can make sure that I'm going to get an integer. So 10 double/3 would give me an integer. Int 10.3, so convert 10.3 to an integer, and then do division. Well, an integer of 10.3 is 10. 10 divided by 4, unfortunately, I'm going to get a float, right? If what I wanted was an integer. All that I end up losing is the 0.3 resolution of that. How about quote 3 times 6? Do I get an integer? Do I get a float? Well, anything inside of quotes is a string, so all I'm going to get is a string of 6 threes in this case. How about 16 asterisk asterisk? If you remember, this is the operator for exponents. And then by 1/2. What am I going to get here? 16 asterisk asterisk 1/2. Let's see. Let's get my Python window open here. All right, so this is an exponent of a fraction. Well, it's the square root of 16, I'm gonna get 4. But whenever I use exponents, I'm definitely gonna get an integer. But I may get a float as a result. Try that one. How about 3.14159 times 2.4 double divided by 5.6? Well, it says integer division, right? So what do I get there? Try some of these out. See what kind of data type you get. You might not get the results you expect to get, but give them a try, first guess, and then put them in idle and check them out. So the math library extends the capabilities of Python by giving us access to some other standardized constants like pi, but also some very standard functions like sine, cosine, and tangent. On page 68 in table 3.2 of Zell, at least I believe that's the right page number, there's some of the most common math library functions there. Sine, cosine, and tangent, which by the way, they expect the angle in radians. So there's a radians function as well. So if you have 30 degrees and you want to find the sine of that, you have to convert 30 degrees to radians first and then sine. There's a lot of very standard math functions in there. There are 3 ways that we can add the math library to our program. So this will be done up at the top. We always add import statements at the very top of our Python program. You could say import math, very simple statement, adds the math library to your program. And then in your program, you could do something like x equals math.py. So you're saying from the math library, grab the pi command, which is pi to a very accurate resolution, times 10. So 31.419 something, 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 that gets assigned to x. And then y is math dot the square root of whatever x was. So the square root of 31 something, right? Which is 5 something. And that'll get assigned to y. So this would work, but you notice I have to add math dot in front of all of my math functions. If I say from math import star, then any math function is now accessible just with its name. I don't have to say math.pi, just pi. X equals pi times 10. Y equals square root of x. So that works. Or I can import just the functions from math that I need. If I only need pi and square root, there's no reason to import the entire library. I can say from math import, and instead of star, just pi comma square root. Just import these two functions, and then I can still refer to them by their name. So there's a benefit to doing this. Your program's not quite as slow as it would be if you imported all of it. Also, that means that if you had your own functions named sine or cosine, the math library wouldn't overwrite those. So we'll talk more about that later. This is sort of the preferred way to do it from a given library, math, whatever. Import just the things you need. But if you know you need the whole library, just say from the library import star. You can also do it this way. Just remember, you have to have the name of the library dot the command you want to use. As I said, sine, cosine, and tangent require radians. So if I say from math import cosine and angle equals cosine of 60, then it's going to, when I print the cosine of 60, it's going to give me this weird number. But the cosine of 60 is 0.5. This is not the cosine of 60. So I'm getting something wrong. Well, that's because I had to convert it to radians. So from math, import both cosine and radians. Angle equals the radians of 60, cosine of the angle. That's my cosine. Now, this little decimal place way down here is just a rounding thing. From math, import cosine radians. How about cosine, and then inside the cosine function, radians 60. We've done something like this before, right? Eval, inside the eval parentheses, input, and then the prompt for the user to enter a value. So you put one function inside another. This is called nesting, by the way, and it's very commonly done. Either of these is correct. Doesn't matter which one you do. Just depends on how readable you want your ending code to be. So how about this? What if we wanted to write a program that determines the shortest possible ladder required to reach the roof of a house when it's leaned up against the house? So the first thing we want to do is prompt the user for the height of the house. That's going to be this, right? The height of the house. Then prompt the user for the angle of the ladder. If I know the length of one side of a triangle and the angle of the opposite side, in fact, I can determine the length of the longest side. This is just a right triangle, right? So in this case, it happens to be the formula I would need is length equals height divided by sine of the angle. Or in Python, sine of the radians of the angle, right? So we could add the commands in between our comments here to actually do this program if we knew the angle of the ladder and the height of the house to tell us how long the ladder must be, right? And we can do that with the tools that we've now learned with the math library and making sure we have the right kind of data types and so on. All right, now an accumulator is a variable that goes inside a loop, like a for loop, that accumulates or collects a value. Think about factorial, the factorial function. Inside the factorial function, you have to have an accumulator, right? You're going to loop from some number down to 1, and you're going to continually accumulate a value. So 3 factorial says start at 3, go backwards down to 1, and accumulate the current number times the next number. 3 times 2, save that, times 1, that's my result. Or 5 factorial. 5 times 4, save that number, that's 20. Times 3, that's 60. Times 2, that's 120. Times 1 is still 120. So we have a accumulated value that gets collected up inside, potentially inside a loop. So a factorial loop might look something like this. N equals the integer of the input that a user might provide. So you prompt the user with please enter an integer. They type in, let's say 5. You start with fact equals 1. That's my accumulated value. For each value in the range from what they entered, n, to 1 by -1s. We're going to count backwards, aren't we? Fact equals itself, which started at 1, times the current value. If n was 5, it would start with 5. It would say 1 times 5, 5. Then it would loop back up. Value would become 4. 5 times 4, 20. Loops back up, right? It's just going to keep accumulating a value. In this case, fact is the accumulator, And inside the loop, the accumulator gets increased by the current factor. And after the loop is done, notice this print is on the same indentation as the for loop. This indented line is what gets repeated inside the for loop. When the for loop is over, then it prints the factorial of whatever value the user entered in here is the accumulated value of my loop. So they could type in 100, they could type in 100 million, and it would come up with the accumulated value. That would be a very large number, right? I'm assuming it would display that in an exponential notation. I don't know. But the accumulated variable will accumulate or collect the results of each loop's interaction. You're going to write loops with accumulators. You're going to write loops with that go forwards or backwards, up to or down from a number the user enters. And in fact, one of the things you should start considering working on is milestone 1 of your project. And you're going to have a number of things in there that include for loops, maybe even accumulators, and so on. All right, that's it for our lecture today. For this lecture, and this is the last lecture in Unit 1-2. Take the quiz for it. Go get started on homework 1-2 and programming exercise 1-2. And remember, we are available for you. Get on Piazza, post your questions. There's regular help hours that start Wednesday, September, I believe, 2nd. And they run Wednesdays through Mondays. So there's always somebody around, or almost always someone around to answer questions. Have a great day. Code on, Python warriors. Code on.